video lecture series of embedded system. So if you are visiting the channel for the first time, please to subscribe to the channel and also please to follow us on Instagram. That is, follow us on the Instagram page of EC Electronics. And if you want the notes and the PPTs of these videos, please to subscribe to the Telegram channel also. Okay. So this is the video lecture series of embedded system. In today's video, we are going to discuss about HDLC protocol. Okay. So let us see about HDLC protocol. HDLC means it is high level data link control protocol. Okay. So this HDLC is a standard protocol for data link network. We know that there is various layers of network as per the TCP IP or OSI model. And there is a layer called data link layer. And for the communication in the data link layer, we generally go for HDLC protocol. Okay. And for the synchronous communication between two data link layers on a network, we use HDLC. There are two frame formats. We know that for these protocols, there are frame formats, right? Or frames. There are two frames or two formats. Standard HDLC is there and also extended HDLC is there. Okay. We'll be seeing both the frames in this video. Okay. So let us see the details of HDLC data frame. So this is the standard HDLC data frame. Okay. Now let us see what are the fields. First one is flag. There are 8 bits for a flag, and this flag is indicating that this is the start or the stop of the bit. And also for the stop end or the tail end, there is again a flag. So totally 2 flags are there. There is no distinguish between there is a start or a stop. The ends are actually placed with 2 flags. That is a concept. Okay. There is one flag towards the beginning, one flag towards the end. There is an address field with 8 or more bits. Okay. Then there is a control field which is having 8 bits or 16 bits. Now here comes the difference between standard HDLC and extended HDLC. Okay. In the control field, for a standard HDLC, there is only 8 bits. For extended, it is 16 bits. Next comes the information field. Information field is actually variable in length. Generally, it will be multiple of 8 bits. See here, 8 into n bits. So totally, it will be multiple of 8 bits. Okay. Next field is called frame check sequence. It will be having 16 or 32 bits. Okay. Next, we are going to see these fields in detail. So this is the data frame structure of a HDLC protocol. First one is flag bits. So the frame start signaling flag bits. Again, for ending of the flag bit, ending of the frame also, there is a flag bit. So the flag bits are 0, then 6 ones, 0. So this is the structure of a flag bit. So whenever a receiver is getting this flag bit, it should understand that this is the beginning of the next frame. Okay. And also another thing to be noted here is that note that the end flag of one frame may be the beginning flag of the next frame. Okay. So likewise it will go on. So whenever it is whenever it is getting one flag, it should understand that it is the beginning. Next flag it is receiving means it should understand that it is the end. Likewise it will go on. Okay. Next one, address bits for destination. 8 bits in standard HDLC format and 16 bits in extended format. Okay. Extended HDLC mostly have 16 bits for the fields. Here for the address bits for destination, in the standard HDLC there is only 8 bits. But for extended HDLC there is 16 bits. Okay. Next one, control field. So the control field distinguishes between the different type of frames. Now if you observe the HDLC, there are mainly 3 type of frame. Information frame is there, supervisory frame, or it is also called as control frame. Okay. Various types of frames that we send in HDLC packets or HDLC frames is there will be information frame, then there will be control or supervisory frame, that is a name, supervisory frame, then unnumbered frame. See here, you can see that in the field, now there is information, right? Sometimes it will be supervisory data or control data. Sometimes it will be unnumbered frame. Okay. So likewise, there are various frames based on the content. Okay, we'll see that in detail. Let us understand this basic concept. Now, the first 1 or 2 bits of the field, which is the control field, determine the type of frame. Let us go back to the data frame structure. See here, there is a control field, right? And in this control field, the first 2 bits is indicating that what is actually this type of frame, whether it is an information frame or whether it is a supervisory frame or whether it is unnumbered frame. This control field, if you look into this control field, you can understand. Okay, I hope you understood it. Next, the field also contain information which is used for flow control and link management. Okay, so this control field is actually a field which is determining what type of data frame we are actually sending, whether it is an information frame or a control frame or an unnumbered frame. And also, we can understand this thing by looking into the first 2 bits. Okay, and this control field is also used for control purpose, that is flow control purpose and link management purpose. Okay, next. Information field. Okay, information field, as we have seen here, see here. This is an information data frame. So it is having information field. Okay, and this information field is actually holding the information. It is variable in length and mostly it will be multiple of 8 bits. Okay, let us see that detail. So information does not have a specific length. In practice, it is normally maximum length determined by the particular implementation. Okay, information frames, also called as I frame, are the frames only that is having information. Okay, information which are normally in the form of fixed length block of data or several kilobytes of length. Multiple of 8 bits it will be having. Okay, all other type of frames normally have empty information. Okay, so here we have actually demonstrated, if you see this data frame, this is the demonstration of a information data frame. So that's why there is a field called information. If this data frame was a supervisory frame, then there won't be content in information field. Okay, that will be empty. Or if it is an unnumbered data frame, this field which is named as information field will be empty. Okay, only the information data frame is having the content or data present in the information field. Okay, I hope it is clear. Anyway, we are going with very simple explanation, so that only required data I have included in this PPT. Okay, unwanted details I have not included because it is very difficult for people to understand all the concepts. So the required amount of data and the required information only I have included. Next is frame check sequence. Frame check sequence field contain error checking bits, normally 16-bit with a provision for increasing this to 32. 8 bits in standard HDLC format and 16 bits in extended format. Okay. Now the purpose of FCS, that is frame check sequence. Frame check sequence means it is actually used for error controlling or error checking purpose. Okay. And 8 bits will be there in standard HDLC, 16 bits will be in extended HDLC. Okay. So that's all about frame check sequence. Now we have actually discussed this thing. Anyway, let us see that in detail once again. There are mainly 3 types of frames in HDLC. Information frames are there. It is also called as I frames. Then supervisory frame is there and unnumbered frame is there. The purpose of information frame is to transport the user data from the network layer. That is, in order to transport any information, we are actually using information frame. Now, what is the purpose of supervisory frame? So, when we are sending supervisory frame, the field called information will be empty. Okay. So, this supervisory frames or S frames is used for flow and error control. These are actually control frames. Other name of supervisory frame is control frame. They are used for flow or error control. Now, how will you distinguish that we are sending a supervisory frame? If you are sending a supervisory frame and if you are looking into the control field, you can see that the first 2 bits will be 1, 0. Okay, if it is first two bits of control field is 1 0, it indicates that that is a supervisory frame. Last type of frame is unnumbered frame or U frame, and it is used for various miscellaneous purposes like link management and contain an information field depending on the type. Okay, some U frames is having information field also depending on the type. Okay, so it is used for miscellaneous purposes like link management. Okay, so these are the various frames. So when you're writing your this topic in your examination, you should write at least this much of things. I've only included for every area. I've included only the required points. Okay, next one. Okay, so let us see the control field structure. If you don't understand what I'm talking about, see here, there is a control field, right? This control field, how it will look like, let us see. Now this will clearly vary based on the type of frame that we are sending. I think at least that much you understood by the explanation till now which I've given. Okay. Now this is the structure of the control field based on the type of frame that we are sending. If it is an I frame or an information frame, it will look like this. First will be 0, then send sequence number, then poll/final, then receive sequence number. We'll see what are these things. Anyway, just understand that this is how it will be looking like if we are sending a I frame or an information frame. Next one, if you are sending a supervisory frame, then this will be the structure of the control field. 1, 0, type, poll/final, receive sequence number. Then if you are sending a unnumbered frame, it will be having 1, 1, type, poll/final, type. Okay. So while explaining the different types of frames, I have given you that if you are sending a supervisory frame, the first two bits will be 1, 0, right? So see here, it is 1, 0. And another thing we understood from this control field structure is that if you are sending a U frame and there is unnumbered frame, first two bits will be 1, 1, right? So if you are receiving a 1, 0, understand that it is a S frame. If you are receiving a 1, 1 in the control field, first two bits, then understand that that frame is a U frame. Okay, see here. We have already written it here. Supervisory frames is having 1, 0. Then if it is a unnumbered frame, it is having 1, 1. Okay, next. For the extended HDLC control fields, this is how it is looking like. So extended HDLC means the control field is having how many number of bits? 16 bits, right? So if it is extended I frame, then it will be 0, then send sequence number, then poll/final, receive sequence number. Then if it is extended S frame, then it will be 1, 0, type, then 0, 0, 0, poll/final, receive sequence number. Okay, so this is how it is going on. Next, let us see what are the receive sequence number, send sequence number, all those things. Okay, so what is NR? NR is the receive sequence number. Both I and S frames contain receive sequence number. NR provides the positive acknowledgement for the receipt of I frames from the other side of the link. Okay, receive sequence number means whenever a receiver is receiving a particular data frame from HDLC, then the receive sequence number means the sequence number of that particular frame which is received. Okay, then NS is the sequence number of the send frame. Whichever frame it is sending, the sequence number of that frame is called send. That is, sequence number of send frame is NS. So NS is the sequence number of frames sent and NR is the sequence number of frames that are received successfully. Only this much of information is necessary. If you observe or if you look into the Google, you will get a lot of details regarding this NR and NS. I don't think that much of data is required for you. Okay, so only this thing, at least you should know this much. Okay, next. So that's all about NR and NS. NR is receive sequence number and NS is the send frame sequence number. Okay. The first frame transmitted in the data transfer has send and receive sequence numbers 00. For the first time, if you are transferring the data using HDLC, the first frame that is having sequence numbers NR and NS 00. Okay. So that's all about NRNS. Next is P/F. Pole final is a single bit with two names. Okay. Now what is P/F? You can see it here that P bar F is actually one bit. Okay. Now it is called pole when it is a part of command, and when it is part of response, it is called as final. In other case, the bit is clear. Okay, so when it is a command, it is called a pole. So when this is a part of a command, it is a pole. Now set by the primary station to obtain the response from the secondary station. In order to poll the secondary station, this field is set by the primary station when it is given along with a command. Now, it is called as final when it is part of a response. Consider that the secondary station is indicating a response to the primary station. So then it is a part of response. Then it is called as final. Okay, so final when it is a part of response set by the secondary station to indicate response or end of transmission. So consider that there is two stations. There is a primary station and there is a secondary station sending data with each other. Primary station is sending the data, secondary station is receiving the data. So this PBRF field will be pole when it is given by the primary station. Now the primary station is sending the frames, right? In order to check the secondary station, this is been set as pole. Consider that the data send or data transfer is complete. Now the secondary station will indicate that to end the transmission, right? So in this case, it will be final, and this is set by the secondary station. Okay. So just understand that if you don't know or if you are not able to distinguish what I've said, just understand that this field is either pole or final. When it is given by the sender, it is pole. When it is given by the receiver, then it will be final. Okay, at least understand this much. Next, type of function and bit values. Okay, see here you can see that there is fields called function or type fields. See, type fields are there here also. Now here also there is a type field, right? What is type? Type of function. Type means it is type of functions and the bit values. Okay. Now the various type of functions are receive ready, receive not ready, reject, selective reject. Okay. Now the function is positive acknowledgement ready to receive the iframe for receive ready. Now receive not ready means positive acknowledgement not ready to receive the iframe. Consider that the receiver is busy. In that case, it will send back a data frame with RNR. RNR means I'm not ready to receive your data now. Then reject. It is a negative acknowledgement, that is reject. Next, selective reject, negative acknowledgement, selective repeat. Okay. So these two are the negative acknowledgements. The first two is a positive acknowledgements. Okay. Next, let us see how the values are coming. Receive ready means now the receiving side is actually ready to receive the iframe or information frame sent by the sender. And if it is receive ready, the value of that type field will be 00, or specifically in order to match the exact size of the data frame, it will be 0x00 in hex. Okay. Next, receive not ready, that is RNR, means it is indicating that the receiver is now not ready. The bit value is 10. Then reject. Reject means rejecting the whatever data frame is sent by the sender. The value will be 01. Selective reject means it is the bit value will be 1 1. Okay, so these are the various types of functions. Now these are actually used for indicating whether the receiver is ready or whether the receiver is not ready. Sometimes it is used as an acknowledgement also. Okay, so that's all about HDLC protocol. We have discussed about all important details of HDLC. We have also seen the frame structures for standard and extended. So I'm really hoping that this video was to the point. So if you're finding these videos useful, please do subscribe to us. Most of the people are still watching the videos without subscribing. So please do subscribe to the channel for future videos. And also, if you want daily recruitment updates also, please do subscribe to us. Okay. And follow us on our Instagram page. And for notes of these videos and in order to get the notifications of videos, please do subscribe to the Telegram channel also. That's it. Thanks for watching and keep on watching.